Hi, this is Ambika, Assistant Professor, Department of AIML. Let us discuss about architectural patterns for dependable systems. So before that, let us go for a small recap. So what do you mean by dependable system? It is nothing but building a trusted software for the users with the key attributes like reliability, availability, safety and security. So dependable system, it focus mainly on the four attributes. Reliability is nothing but continuing the service without any errors. Availability is nothing but the system is ready for the use and accessible to the users. Safety is nothing but we mainly focus on the absence of the catastrophic consequences. So security is nothing but protecting the system from the malicious threats. So here the architecture design, it mainly focus on preventing, detecting and tolerating the faults. Role of the architecture in dependable system. So mainly the software architecture defines the following components like what are the system components and how they interact between the components, what are the control and data flow and also the deployment structure. So for dependable system, the architecture mainly it focuses on minimizing the failure, it supports the fault detection and recovery, it enables the redundancy and isolation and also ensures the secure communication. Next comes the architecture pattern types. So redundant architecture pattern. So there are three types of the redundancy. Hardware redundancy, it mainly focuses on duplicating the processors, servers like that. Software redundancy, it focuses on multiple implementation of the same function. Next comes the information redundancy. It mainly focuses on duplicating the data. So here the example is aircraft flight control system. It uses a triple modular redundancy. It's nothing but three identical systems will be parallelly, simultaneously will be executing. And in case of the auto mechanism, so the maximum output system will be considered. So here the advantages, it will be having the high fault tolerance and also the availability will be improved. So here if you consider the limitation, it focuses on the increased cost and complexity. Fault tolerant or recovery block pattern. So it consists of primary component, alternate component and acceptances. So in primary component, so the first version of the algorithm will be executed. So if it fails like that, we will be going for the alternate component. It consists of the different versions of the same algorithm. So once the primary component algorithm it fails, we go back for the alternate component and then we'll be conducting the acceptances. If the primary component it fails, then we will be executing the rollback and then we will be executing the alternate algorithm for that software. So the use cases here are safety critical embedded systems and real-time control software. Next one is end-version programming pattern. So here the main thing is that we are going to develop the multiple independent versions for the same software specification. So the main goal is to reduce the common design faults. So the process here is that independent teams will be creating the different versions for the same software and these versions will be executed parallelly. So using the voting mechanism, so the maximum output will be considered and then those team will be executing the corresponding version of the software. So the application here is spacecraft navigation, nuclear monitoring system. Next one is the layered architecture pattern. So in this case, the system will be organized into hierarchical layers and then once a layer is executed, then it moves to the next. So the benefits of this architecture pattern is that we will be finding the faults within that layer and it is easy for maintaining and verifying the failures and also it improves the security boundaries on that control. So example OS as well as the secure enterprise platforms. Client server with replication. Here the multiple replicator servers will be providing the same service. So here if in case of any failure in one server, so the other servers we can make use of that one. So main benefit is high availability will be there and as many servers are there, the load will be balanced and then the system will in case of the failure, the system will be able to operate that comes under the graceful degradation. So the real world example is the cloud-based application with redundant data centers. Next one is a microkernel or safety kernel pattern. Here the microkernel it manages the essential functions only. That is, it displays the functional as well as non-functional requirements. So it manages the functional requirements. And non-functional requirements will be executed in separate modules. So in case of any failure, it won't affect the functional requirements. So the features include small verifiable kernel will be used. So the external services it will be executed in isolated modules. So the failure won't affect the main thing. Here in case of this failure, so it will not crash the core system also. So the examples will be, it will be used in safety critical operating system and also in secure embedded system. Supporting mechanisms in dependable architecture. So here, fault detection. So it mainly focuses on watchdog timers. It may be the hardware or software mechanisms for detecting and preventing the faults. Next one is heartbeat monitoring. It mainly focuses and ensures whether the system is operational or not. Next comes the exception handling. It will be executed during the execution of the software. Next one is fault recovery. It is achieved by rollbacking and using some checkpoints. Next also using the restart mechanisms, and graceful degradation will be there. That is, even in case of the failure, the system won't crash as totally. It will be operational at least for some time. Next, security integration is achieved by authentication. That is nothing but identifying the users. Authorization is access control, and also through the secure communication, and also some through the intrusion detection. Here the intrusion detection is nothing but it acts like a firewall. So it will monitor whether the threats has been occurring or not, and it will alert the monitors so that it comes under the intrusion detection. Next one is the comparison of these patterns. So the patterns are like redundancy, recovery blocks, inversion, layered, replicated client server, as well as a microkernel. So it focuses on some strengths like availability, and recovery blocks it focuses on fault correction, and inversion it focuses on the fault tolerance. Layered it focuses on the isolation and maintainability. And in case of the client server replicated architecture, so it mainly focus on the scalability and uptime, and microkernel mainly on the security and verification. Thank you.